So if you have got a value 2 moles per liter of a molarity, you can directly write 2m that represents same. That means 2 moles of solute in 1 liter of solution. Is that clear?
Yes, sir.
Now, as you can see, you know how to calculate the number of moles. So I'm gonna directly give you question, and there is a lot of questions that comes on molarity. So we are going to discuss each one of them. So you can see the question. I'm gonna give you 49 gram of H2SO4 present in 250 centimeter cube of solution. Calculate molarity. Can you do this, or I should explain the first one?
Sir, can you explain?
Okay. So whenever you are going to solve a numerical, the first focus you are going to give is on the given quantity that you can see in a solution. There is H2SO4, which is 4.9 gram. That means given mass of solute, that is H2SO4, that is 4.9 gram. And it is also given that the volume of solution 250 centimeter cube. The volume of solution is 250 centimeter cube. Now, as you can see, I'm gonna nothing given more than this. So what we need to calculate molarity. So simply, you are going to write the formula of molarity. And what does formula of molarity say? It says that number of moles of solute upon volume of solution in liter. So first of all, you can look at the volume, and volume is in centimeter cube. So do you know how to calculate or how to convert centimeter cube into liter? Yes
100
or no?
centimeter cube is equal to liter. I mean,
No,
1000
no, no.
centimeter.
Basically, yeah, 1 ml is equal to 1 centimeter cube. So if you want to divide it, convert it into liter, you are going to divide it by 1000. So it will be in liter. So if you are going to convert this volume of solution in liter, what you need to do, divide it by 1000 and you will get it in liter. Now you can easily solve it and it will be 1 by 4 liter. Also, we need to we need to put the value of number of moles of solute, and here mass is given, so you can easily calculate the number of moles of solute. That is H2SO4 is the solute. Given mass, that is 4.9, and molar mass is 98 that you have calculated. So you can see decimal, if you are going to remove, there will be 10, and this will be cancelled by 2 times. So the number of moles will be 1 by 20. Now I'm just going to put the value. Number of moles of solute is 1 by 20. Number volume of solution in liter is 1 by 4. This is your moles and this is your liter. I'm just writing the unit so that we will be able to know what is the unit at last. Okay. So I'm gonna just solve it 1 by 20 and 4 by 1. And here it will be moles and here it will be liter. So you can see 4 5s. So it will be 1 by 5, 1 by 5, or you can write 0.2 moles per liter, or either you can write 0.2 m. Okay, so isn't it easy?
Yes, sir.
So let me know when to change the slide.
Done, sir.
Okay, now I'm gonna give you just wait a minute, let me change this. Are you able to see the screen?
Yes, sir.
Okay, so I'm just gonna give you 0.71 gram Na2SO4 is presenting 500 ml of solution, calculate molarity. Let me know. Will you be able to solve this? Then
1 minute, sir.
no.
So it's 1/10 m.
Okay, let me just check it. You can see this is your given mass and this is your volume of solution. So you know that molarity has a formula, number of moles of solute and volume of solution in liter. So as you can see, number of moles of solute, that is given mass upon molar mass. What is the molar mass of Na2SO4 you have calculated?
142.
That's great, 142. And you know the volume is in milliliter. And if you want to convert it into liter, it will be this, right? So I'm just gonna solve it, simplify it. 0.71 upon 142 into 1000 upon 500. Now gonna solve it. You can see this 0 will be cancelled and this will be of 2 times. And if you are going to remove this decimal, 100 will be divided in numerator and this will be cancelled by 2 times and this 2 and 2 will be cancelled. So you will have 1 upon 100, that means 0.01 mole per liter or capital M. Let me cross check it. It will be
Yes, sir. 1
here
by
you
100
have.
only. I forgot to add 0 to 100.
Yeah. What did you just say?
Uh, Final answer, I forgot to write 100. I wrote 10 instead.
Oh, okay. Okay. Have you written it? Can I move to the next question?
Yes, sir.
Okay. Calculate the molarity of following. The first one is 49% weight by volume H2SO4. The second one I'm going to give you is 10% weight by volume calcium carbonate. Please calculate the molarity.
Okay, sir.
If you are not able to solve it, just let me know.
Sir, could you show the first one? I'll do the second one.
Okay, you should, by the way, you should try. If you're going to try it by your own, a new question, it will be helpful. I'm just going to give you hints, not going to solve it.
Okay, sir.
Can you tell me a whole sentence about this, the way I told you when we were studying weight by weight percent or weight by volume percent? Tell me, what does this means?
49% of solute in 100 ml of uh,
Again, go for 49. After 49, what did you say? 49?
49 grams of solute in 100 ml of solution.
49 gram of solute, right? Present in, now your question is solved, 100 ml of solution. Can you look at this sentence carefully and what you need to calculate molarity? Molarity is number of moles of solute upon volume of solution in liter. You can see given mass. With the help of this, you can calculate number of moles, right? And volume of the solution is what? 100 ml. Can
Yes,
you
sir.
calculate it now?
Yes, yes.
So you should try by your own. If you are going to do a right question, a new question by your own, that will boost your confidence. Just let me know when you are done with this. Let me know the answer.
Okay. It's 5 m, sir, for H2SO4.
Okay, just let me check. Number of moles of solute. That is given mass 49 upon molar mass 98. Volume of solution 100 upon volume of solution in liter, then divided by 1000. So you can either easily solve here 1 by 2 and this will be cancelled by 10. That means 1 by 2 upon 1 by 10. This 10, we are going to write it like this. So that's great. You have got the right answer. Please do the second one.
Sir, 1 m for CaCO3.
1 m. So I'm just going to check it. Given mass 10 gram upon molar mass this, then 100 divided by 1000. This will be like this. So I'm just gonna check it. So 10101010 will be cancelled. 10. Yeah, that's great. So that means you can easily calculate, right? Okay. I'm just gonna give you another type of question. Another type of molarity basically. So you can easily calculate the molarity questions on molarity which are directly given. You can put the value in the question and you will get it. Now, how we calculate molarity on dilution? You know what does dilution means? Dilution means basically it means addition of solvent, or in our term generally we do dilute by water, addition of water or solvent. So let's see, there is a container. In this container, molarity is, let's say, M1 and volume is V1. And here, number of moles of solute. This N stands for number of moles of solute. Number of moles of solute. Let's say if you are going to add some solvent or water, let's say you are going to add water, then you know the volume of solution will change, yes or no?
Yes, sir.
Now, if the volume changes, that means molarity also changes. But can you tell me, if you are going to add solvent, will it affect number of solute? Will it increase or decrease number of solute, or it will be as it is? The number of moles of solute will change or it will be constant. What do you think?
It will be same.
It will be same. That means number of moles of solute here will be same as the previous one, because you added water. That means solvent will increase, but the solute will be similar. Now, what I'm trying to do is just basically derive a formula. So if you are going to apply the formula of molarity on this container, M1 will be equal to number of moles of solute N1 upon V1. I'm just okay. N upon V, it will be yes or no?
Yes, sir.
So N will be equal to M1 V1, N1 V M1 V1. And when you are going to again do the same, M2 will be equal to N upon V2, and again N will be equal to M2 V2. By the equation, if you are looking at the this equation, second equation and third equation, both are equal to N. That means they are equal to each other. N is equal to M1 V1 and N is also equals to M1 V2, M1 M2 V2. That means from 1 and 2, that means M1 V1 is equal to M2 V2. Yes or no?
Yes, sir.
So simple. Whenever a question comes, calculate the molarity of this. When you are going to dilute it, you will be writing M1 V1 is equal to M2 V2. Okay. So please do write this, and then I'm going to give you a question on this.
Yeah, done, sir.
Okay. So I'm going to give you a question on this, which is very easy. So the question is first, 0.5 m HCl in 250 ml of solution, which is diluted with 250 ml of water. Calculate new molarity. Can you solve it?
Yes, sir.
No, please do it. Are you done with this? Are you done with this?
No, sir.
Okay, I'm going to explain. It's very easy. First of all, this is your M1 and this is your V1. And you cannot say this is your V2 because according to the question, according to the language, you can see molarity is 0.5 m, that is good. And the volume is 250 ml, right? Now you are going to add 250 ml more in this container. That means basically this container, the new container, molarity we need to calculate, final molarity we need to calculate. But if you look at it, what will be the volume? Volume initially it was 250 ml and then you added 250 ml more. The final volume is equal to 500 ml. Yes or no?
Yes.
So that means this is your M1, this is your V1, this is your M2 that we need to calculate, and this is your V2. So since you can see that this is about dilution, so you are going to apply the formula M1 V1 is equal to M2 V2. And you know the value of M1 that is 0.5 and V1 that is 250, and also M2 is there and V2 is now 500 ml. So M2 will be equal to 0.5 into 250 upon 500. You don't need to change it in liter. If you will change it, that will not affect. It will take your time. But you can see both are in ml, so it will be cancelled. That's why we don't need to change here. ml here and ml here, that will be cancelled. So you can see 25 twos, and you can see the m2 will be equal to 0.5 by 2m, or you can easily calculate it 5 by 20 it will be, and then 1 by 4m, and you can see it will be 0.25m, right? Yes or
Yes,
no?
sir.
So it is so easy. Can I change the slide?
1 minute, sir.
Okay.
Done, sir.
Let me be the host, then I'll share the screen. Mohammadin, am I audible?
Yes, sir.
Okay. Now I'm. So have you written it all?
Yes, sir.
Okay. Now we are going to this. Whenever the questions on molarity will be there, then you are going to apply this formula M1 V1 is equal to M2 V2 and focus on V2. If the sentence will be like it is diluted up to 500 ml, that means the final volume is 500 ml. But if the sentence is like it is diluted with this ml of water or solvent, then you are going to add it. So I think you can easily understand the language, right?
Yes, sir.
Now, the next type of molarity questions on molarity is that molarity of mixture. That means basically there is two container, one container, and there is another container, this container. Now, this has the molarity M1 and volume V1 and number of moles of solute N1. Again, this has number of moles of solute N2, molarity M2 and volume V2. Now, what you are going to do, it's very simple. What you are going to do, it's very simple. You are going to mix these two containers in a bigger container. Container. How you are going to mix it? You can see this is the bigger container in which you are going to mix the both. Now this will have molarity, let's say M, and the volume V, and the number of moles of solute N. And you know that since here is number of moles of solute N1 and here is number of moles of solute N2, and if you are going to mix them, the final number of moles of solute will be N1 plus N2. Yes or no?
Yes.
Now, can you tell me the volume of the solution in bigger container? You can see if this container has V1 and this container has V2, and you are going to mix them in a bigger container, then this volume will be equal to V1 plus V2. Yes or no?
Yes.
So it's very easy. Now I'm going to apply the formula of molarity here. M1 will be equal to N1 upon V1. So N1 will be equal to M1 V1. Now here you can see M2 is equal to N2 upon V2. So N2 will be equal to M2 V2. And in the bigger container, you can see if you are going to apply the formula for M and V, M will be equal to N upon V and N will be equal to M into V. It will be equal to like this, yes or no?
Yes, sir.
Now, you know that in the bigger container, N is equal to M1, N is equal to N1 plus N2. And this N has a value MV, final molarity into final volume is equal to N1. N1 has M1 V1, so you are going to put M1 V1 plus N2 as a value M2 V2, so you are going to write here M2 V2. So the resultant molarity or the molarity of mixture will be equal to M1 V1 plus M2 V2 upon V, you can write, or either you can write, since you know that V will be equal to V1 plus V2. So the final formula will be equal to, so the final formula will be equal to M will be equal to M1 V1 plus M2 V2 upon V1 plus V2. Oh, wait a minute. So it's very easy. You can see M1 V1 plus M2 V2 upon V1 plus V2. So this is the final formula for the molarity of mixture or the resultant molarity on mixture. So please do write it and let me know when you are done. Please do write it and then
Yes, done so. Sir, the total volume should be in liters, right? Or ml only?
Humamuddin, what did you just say? Total volume?
Should be in milliliters or liters?
It will not affect us actually. What happens if you will look at the formula, you can see there is volume term, either it will be in ml, in numerator as well as in denominator. So they cancel each other basically. Are you getting my point?
Yes, yes, sir.
And if it will be in liter, it also cancel each other. So we don't waste time here to convert it into liter or ml. If one of the mixture, one of the container has ml or liter, then we have to convert them in same unit. Are you getting my point?
Yes, sir.
Okay, please do it. Are you done with this?
1 minute.
Okay, okay.
So it's 125.25 divided by 2.
Just let me check. Final molarity will be equal to, this is your M1 and this is your V1 and this is your M2 and this is your V2, right? So if you are going to write 0.5 into 250 plus 0.25 into 125 upon, we can write 250 plus 125. 250 plus 125, that will be equal to 375, right? And
Yes.
if you are going to multiply this quantity 0.5 into this, so it will be 125, plus if you are going to multiply this 0.25 into 125, so it will be 31.25, and if you are going to add this, so it will be 156.25. What was your answer?
125.25.
Oh, you can see if you are going to multiply this alone, it will be 125. And if you are going to multiply this, it will be 125. Again, I'm going to just cross check it, 31.5. And then if you are going to add this, then 156.25 upon 375 you will get. Okay.
Yes, sir.
Now, in the next class, we are going to introduce the last concentration term, and then we will go for solubility, the main topics of the chapter.
Okay.
Please do it.
So 10 m.
10 m. Let me just for molar mass is what? NHCO3. What is the molar mass?
84.
84. Volume is 100 centimeter cube. Just convert it into liter. So divided by 1000. So you can see it will be like this, and then this, and this will be cancelled. Then 10 will be here. This and this will be cancelled. 1 m it will be, right?